Hello everyone. Today I am going to discuss modern developments in carding. As you all know, the importance of carding machine, and it has always been considered to be a crucial process for spinning good quality ring spun yarn. The importance of carding has become still greater when spinning on new spinning systems. It's a general perception that higher the production, the more sensitive is the carding operation and greater the danger of adverse effect on quality. But practically, if the card is well maintained, the production could be increased without adversely affecting the quality. If we see in last 60 years, production of card has gone up from 4 kg per hour to 100 kilograms per hour. This could happen because of some important developments during this period. Like in 1950s, with lab feed cards, the production was around 4 kg per hour. In 60s, metallic wire points were introduced and production increased up to 20 kilograms per hour. Then in 70s, cylinder speed was increased with some modifications and production increased up to 30 kilograms per hour. Then development of carding elements came into existence and production increased up to 40 kilograms per hour. In 90s, better pre-carding increased production up to 60 kilogram per hour, and after 2000, cylinder speed increased up to 600 rpm and production increased up to 100 kilograms per hour. So some of these developments are listed here: shoot feed to card or direct feed to card, unidirectional feed, use of carding segments under taker in, use of carding segments around the cylinder, apron toffing, higher cylinder speed, high performance card wire, online monitoring of naps, auto labeling at card, then integrated grinding system. So we'll discuss all these points. Today I am taking shoot feed to card. The shoot feed system, which feeds well opened fiber tufts without compressing them into a lap to a set of cards, has become nowadays an important part for high performance carding because it improves productivity of card significantly with some other advantages, like it eliminates manual effort in carrying laps from blow room to card. Also, it avoids making clean waste during lap change. Now there are two basic shoot feed systems. These are single shoot feed system and double shoot feed system. This is single shoot system. Example of single shoot is Reiter arrow feed. Here is central distributor arrangement is there. This is the flock feeder, which provides a gentle opening of material and distributes material to the connected 5 to 8 cards. If you see this flock feeder, number 1 is the feed duct from blow room line. So open material comes through this with the help of this cage. It fed into this feed duct. Then there are delivery rolls. Then a Krishna beater is there, which provides a mild opening to the flocks coming from blow room line, and it feeds the flocks, open flocks, into this suction duct. Now, if you see the arrangement of cards, all 5 to 8 cards are connected with a ring duct, this number 6. This is elevation, means side view, and this is the plan, means top view. flock feeder is this one. So after opening, material comes into this suction duct, which is connected with this blower fan number 5. This is flock feeder and blower fan number 5. It blows material into this ring duct this way, number 6. Now all cards are connected with this ring duct. After feeding material to all cards, the remaining material will again come back to the flock feeder. For feeding to individual cards, there is an arrangement. Delivery head is there for every card. Inside the delivery head, there is a adjustable nose which ensures equal feeding to all the cards. There is a single chute behind each card, and after feeding all the cards, remaining material will again come back to the flock feeder. This number 11 is the return duct. After returning back, these flocks will be fed to the second feed duct number 4. Air will be escaped through this number 5 and flocks will be dropped into this feed duct. Again there are pair of delivery rolls. These flocks are again fed to the Krishna beater. So along with the newly fed material, it will be opened and again it will be fed to the suction duct, and through suction duct again to the cards. So the main disadvantage of this system is some material remains in the circulation path. So there will be chances of nap formation. Now it has been eliminated in double chute system, where each card is provided with an opening system. This is double chute system. Example of double chute system is Trutzler ExactaFeed FBK. Here a transport duct 2 is there. Raw material travels via this transport duct, which extends over all the carding machines. 5 to 8 cards are connected with this transport duct, and it terminates after feeding the last card. That means there is no circulation of material. Now from this transport duct, material is fed in this reserve duct. There are 2 ducts, reserve chute and final feed chute or final feed duct. That's why it is called double chute feed system, and there is an opening roll in between these 2. So after feeding material into this reserve duct, air will escape through this comb 3 and will return back to the suction duct 1. There is a pressure switch also, which will ensure the level of material into this duct. Then there is delivery roll number 6. An opening roll is there. This arrangement is for each card. So it provides a mild opening, then feeds material into this final feed duct or final actual chute. Here the material is given a controlled condensation with the help of a fan. It blows air, and after feeding the material, this air will escape through the combs number 10. So after this escape, the air will return back to the fan again. So there is a circulation of air. as you all know that whenever we feed along with air, there are two advantages. One is uniform distribution of material across the duct, because air will try to lead towards least covered areas of comb. And second advantage is it provides some condensation of material. Now there is a pressure switch number 8. It will ensure the constant fill into this duct, and when we achieve the level into this duct, it will stop the feed roller number 6, which feeds material to this opening roller. Again, there is a pressure switch into this reserve duct, which works in connection with all the 5 to 8 cards connected. And when all cards achieve the level, it will stop delivery from blow room. So that way there will be no material in the circulation. Finally, the material is delivered with the help of this pair of delivery rollers, and it is fed in the form of sheet to the card, feed roll, feed plate, leckrine, and then cylinder. So this way this double chute feed system works. Now we see advantages and limitations of chute feed system. The continuous or direct feed system or chute feeding system of the cards has many advantages, like elimination of lap making. Now no lap transportation and storage required, saving of floor space due to feed automation, reduces the card tender labor cost. As you know, the manpower requirement in doffing the laps, weighing, transportation to card, and feeding at card is eliminated. Elimination of lap waste with up to 3% saving in reusable waste, because on every lap change some waste is generated. Then reduction of card stops and damages caused by thick lap joints during the lap piecing. Then crushing of foreign material and trash during calendering, and the difficulty of removing at subsequent process is reduced. In chute feed system, the fibers are fed to card in loose sheet form as against the compressed form in the lap feed, so that trash particles can be easily removed from fibers by the carding action. Now there are some limitations also of chute feed system. The blow room should run same number of hours as the cards do, because both are interconnected. If blow room stops, then all cards will be stopped. Then the card production must be kept excessive to assure continuous feed to draw frames at the time of blow room stoppages. And changing from one mixing or blend to another, it will result in more waste in chute feed system due to running out the system. Moreover, in lap forming system, we can control total lap weight and thereby the CV%, but there is no such control in the chute feed system. That's why if we use chute feed system, then it is essential to use auto leveling system. So this is all about chute feed system. Thank you very much.